right, let's do our fourth and final type of stoichiometry problem. In this problem type, our known is going to be in mass, and our unknown, what we're solving for, is also in mass. So what does this mean? This means that you actually have to do the molar mass for both the known and the unknown, okay? So you're going to work two molar mass problems. And when we look at this chart up here, we see that we are going to start off with the mass of our given. Then we are going to put in the molar mass of the given or known. We're going to follow that up with the next part of our train tracks being the mole ratio. So moles over moles. And then once again, another molar mass, this time for the unknown. And then we can plug and chug and find our answer. So let's look at this first problem. It says that sodium peroxide, Na2O2, reacts vigorously with water to produce sodium hydroxide solution and oxygen gas. So we need to go ahead and write out the reaction and also balance it. So what we have here, sodium peroxide. So that's going to be Na2O2, and it reacts with water. So plus H2O, and this is going to yield sodium hydroxide and oxygen gas. Now, once again, this is a great opportunity for you to pause the video, go ahead and make a reactant and product T-table, and to balance this reaction. Now, I will give you a hint on this one. Even though you have water on one side of the arrow and hydroxide on the other side of the arrow, don't break up water into a hydrogen plus hydroxide. Go ahead and separate everything out. So go ahead and in your RMP table, put in sodium and an oxygen and a hydrogen. Okay, so we're just going to break everything apart in this one, and that will actually make it a little bit easier to balance. Okay, so if you had paused the video and you're back with us, hopefully you got a coefficient of 2 in front of your sodium hydroxide, and there is an understood 1 in front of all of our other compounds. Now let's go ahead, I'm going to scroll up a little bit, and let's go ahead and write out our knowns and our unknowns. So the question is, what mass of oxygen is produced when 50.0 grams of sodium peroxide react with water? So our known is 50.0 grams sodium peroxide, and what we're solving for, our unknown, is a mass of oxygen. So before we ever set up our train tracks, we are going to go ahead and solve for the molar mass of the sodium peroxide and for the oxygen. So here we go, sodium, oxygen. We have 2 ions of sodium and 2 ions of oxygen in this formula unit. And when we go to the periodic table, we see that the mass for sodium is 22.99. The mass of oxygen is 16.00. We multiply that out and we're going to have 45.98 and 32.00. Add that together and you come up with 77.98 grams per mole. Now let's do this all over again, and this time for the oxygen. So for the oxygen molecule, there's 2 oxygen atoms in there. Oxygen has a molar mass of 16 even. So that's going to come up to with 32.00 grams per mole. All right, so now we can go ahead and put down our train tracks. Now, these problems tend to be pretty long, so you want to make sure you have enough space. If you're somebody who writes big, you may want to try to write a little bit smaller so that your problem will all fit on across your screen. So we're going to start off by putting in, there we go, our known value of 50 grams of sodium peroxide. And then we can put in our molar mass of sodium peroxide, which is 77.98 grams. Sodium peroxide for every 1 mole of sodium peroxide. Oh, nope, there we go. Now we can put in our mole ratio, excuse me. So if we go back to our balanced equation, we will see that for every 1 mole of sodium peroxide, and hold on a second here because all of a sudden I'm writing the formula for sodium peroxide incorrectly. That should be Na2O2. And for every 1 mole of sodium peroxide, 1 mole of oxygen is going to be produced. Continue on my train tracks. And now I can do the molar mass of oxygen. So 1 mole of, in 1 mole of oxygen, there are 32.00 grams of oxygen. All right, so you're going to go ahead and plug and chug. Once again, you'll multiply the 32 times the 50. Then you'll take that answer and divide it by 77.98. And you should come up with 20.5 grams of oxygen. As always, box your final answer. All right, that is how you do problem type 4, which is a mass-to-mass problem. Now, your homework is to do these 2 problems here. The homework is not going to be due until Tuesday morning, so that's Tuesday the 24th at 8:30 in the morning. Now let's go ahead and talk about this classwork. So because of all the technical difficulties that have been happening, the classwork is not going to be due until Monday morning at 8:30. So that means Flipgrid videos, downloading or uploading those videos to the link that's in your OneNote on the page called Flipgrid. None of that is necessary. None of that will be due until Monday morning at 8:30 because of all the technical difficulties. So now you have seen a video with a review of mole to mole and mole to mass problems. You have watched another video on how to do mass to mole problems. And now this third video on how to work mass to mass problems. So you have all the information necessary in order to be able to do this worksheet. Notice whatever class period you're in, you will have these 2 problems that you need to do, make a video on in your Flipgrid. So don't forget to go ahead and write out your knowns and your unknowns. Set up your train tracks. solve for molar mass where necessary. For these mole-to-mole problems, clearly you will not have to solve for the molar mass of any of those. That's our simplest problem type. But as you scroll down and you see these gram-to-gram problems, yes, you will have to solve the molar mass of both the known and the unknown. All right. I hope that clears up any of the confusion that you might have had about your assignments and your new assignment due dates. Once again, the classwork, that means the Flipgrid videos that are uploaded to that link, will be due Monday morning at 8:30. And the homework pages, which are here and here, those will be due Tuesday morning at 8:30. Once again, those two will be submitted to submission boxes on Moodle, just like we've done for all the other homeworks in the past. If you have any other questions, please let me know.